This is just to demonstrate how LT wire life could be held without experiencing any electric shock. As to ascertain or to show you that there is light or whatever electricity in these wires, I will use it to power this bulb. You can see, which means this wire is carrying electric current. This is the live end of the wire. This is the neutral end of the wire. While I hold on to this live end or live terminal of the wire, a tester will be placed on any part of my body to show you that my body is a conductor and is also carrying the current. Okay, you can see I'm talking, and at the same time I am breathing. I am talking, at the same time I am breathing. I don't want the person testing body to touch mine. Okay, as I held the live wire. Now what next is to explain the science behind what I have just done. So okay, there are certain scientific common parameters here. One is energy, and we all know energy is the ability to do work, and it is rated in joules, whereas power is just the rate of doing that work, which is rated in watts. Q is charge, is measured in coulombs. Then time, T, is measured in seconds. Now, we may wonder, while I was holding that live wire, I was not experiencing shock. Simple. We said energy is the ability to do work. Now, if work is not derived from electrical energy, nothing happens. Look at this bulb, for example. We have the positive wire, we have the negative wire, just as the bulb I was holding the other time. So when it is plugged, the positive end carries the current into the bulb to do work. So when work is done, the whole energy in those charges carrying the current is exhausted. So those charges come out through the negative terminal empty. In other words, they don't have energy with them again. That's why in this diagram you can see the energy being represented by dots while going into the bulb. That's the positive end of the wire. Dots, dots, dots. Look at after entering and the bulb glows, coming out, you can see there's no more black patches again, just green patches only, to tell you that it's still the same charges that are coming out, but without energy. In other words, charges can carry energy and charges may not also carry energy, but they remain as charges. That is why if an ammeter is placed here to measure the current, because the current is a measure of the flow of charges. If an ammeter is placed in series on this wire, what we are measuring there will just be the what? The current, rate of flow of the charges. That same ammeter, if placed there while the circuit is closed, if placed there, the same thing, the same current is measured, because current is just a measure of rate of flow of charges, different from voltage. Voltage is the energy part of this figure. In other words, voltage, which being energy per unit charge, energy per unit charge. In other words, look at the charges here. So the energy being carried per 1 coulomb is what we call the volts. So when there is something called voltage drop or potential difference, in other words, once this energized charges, positive charges, enters the bulb, drop the energy in form of light. After the energy is dropped, the charges come out again to be replenished anyway, but without energy. That is just the explanation. But then, why did I hold on to how did I hold on to the live wire without being shocked? Simple reason is that I am scientifically saying, expressing myself that I am at the same potential with that wire. That wire terminal I'm holding on to is not flowing anywhere through my body. My body and that wire remains at the same potential. That's the scientific explanation. But what do I mean? It simply means I have current in my body, but the current is not flowing anywhere. As long as the current is not flowing anywhere, I will not experience shock. In other words, shock is just a reflection. If you receive electric shock, it's just a reflection of work being done on your body. Work being done on a bulb, for example, is to show light. Work being done on a fan is to roll, etc., etc. Well, on the pressing iron is to heat. But on the body, if I don't allow it to do, I may allow it to do work. I may not allow it to do work. If I allow it to do work, which means it has to flow to somewhere. For example, the earth. If we look at the two wires, live and neutral, I cannot hold on to the two because it will do work on my body. And that work will be experienced on my body as shock. So that work, what you call shock, is really work being done by that electrical energy you allow it to flow through your body. If not, you will not receive any shock. So how did you accomplish that? It's just by insulating my legs. In other words, for example, we know earth is a good conductor of electricity. I will not allow my leg to or any other part of my body to even touch any wall or the floor or the ground. Oh, excuse me. All I needed is an insulator, fine slippers, leather, rubber shoe. They are all enough to do that. But please don't say I did it because I held my breath or because I was not breathing. It's not true. I was breathing. I was talking. I did not hold my breath. I did not stop talking. So that is just the science behind it. If you have any questions, you can meet me in the comment section. Thank you.